When building RAG applications, there are two stages. First stage is basically ingestion, and the other stage is extraction. Ingestion means taking whatever information you have, documents, or any sort of it could be your whole website, convert it into a markdown, whatever sort of information, right? Text information, image, and kind of chunking them into smaller data sets, and then basically we store it in a vector database. And mostly people try to do vanilla RAG. Vanilla RAG, as in just storing the vector information in a vector database. There is no meaning as such. So what happens to showcase that? Basically, look at this document. Looking at this document, when I want to get some information from this document, I may be looking for something like what are the vector databases, right, that are mentioned in this document. So as you can see, as we humans can notice that there is Pinecone, there is Chroma, Milvius, BV8, Fires. So there are 5 vector databases that are mentioned here, and when we store it in database, right, in the vector database, what I've done is we have built this endpoint basically, which converts a PDF into markdown. So I've used this endpoint. I have deployed this into a vector database, and as you can see, here's the vector database. It's Qdrant. Basically, we are using a Qdrant vector database. I've stored the information here in this collection, as you can see, in a markdown format. This is heading 2, and this only stores some information, just the title. Next one stores some paragraph, and then similarly we have some more paragraph and tech capability, stuff like that. There is no the chunking that we have used here is basically, I think, mostly trying to split it into certain chunks. There is no meaning in this chunk right now, right? Everything is scattered into small chunks. And for example, here if you see, there is in. This doesn't really, if I get this as a response, this doesn't really make any sense, right? In, and agent workflows, something till human. So what happens when you do a vector similarity search, right? Let's say if I want to get all the vector databases, right? And if I try to let's say do vector databases, right? So this is what I want to search now for RAG. Let's say if somebody user is asking what are the vector databases mentioned in this document. So what happens here, we expect that it's going to give us all of this Pinecone, Chroma, Milvius, and all of these names. But how does it actually perform? We'll see. So I've requested for like 5 results at a time. So let's see what are the 5 results we get. We get vector databases. Cool. Second result says source vector database designed for AI application. Third one says Pinecone is fully managed vector database. So again we get something like source vector database, source vector search engine. So I actually thought we would have got something like all of these names, right? So this information actually is not being retrieved like we thought, right? All of this information is not being retrieved properly. So how does this work? It's basically a vector similarity. It doesn't have any kind of natural language here. It's just trying to give you what do you say, like a similarity search. For example, why did we say this Pinecone is fully managed? So if you see Pinecone is fully managed vector database, just because this vector database is mentioned here, and this whole thing, right, and this whole thing is being captured within one, I think, let's find where it is, within just one block. Yeah, here it goes. Vector database start from here. See, Pinecone is fully managed vector database, right? That's what we retrieved here for high. So here imagine if we had stored the whole thing as in this whole information which makes basically not this one, sorry, vector databases, this whole entire thing should have been stored as one point, isn't it? Then it would have made sense, because this whole thing belongs into one thing. This thing is basically something that makes some meaning. All the vector databases names are stored together, and let's say tech capabilities, right? So all of these information should have been stored together. Okay, in that case it would have been easier, because this whole thing would have been retrieved if I had said tech capabilities. Then the most similar search would have been this one, because it contains tech capabilities. The whole thing would have been retrieved at a time, like a one vector point, and then this could have been fed into a LLM. It would basically read this entire thing, got all the names from here, and then would have made sense. But in this case, what has happened, we are not even getting that information out. That's where basically your vanilla RAG fails. It all depends on how your chunking matters, and how you have chunked your entire text. In this case, this has been not chunked very well. I mean, it's still in a development phase, so we'll develop it further. We'll basically come up with a better chunking strategy, where probably I think we should use an LLM to even understand and chunk, get that, extract that meaningful paragraph and something that makes sense into one thing, rather than like splitting this in, like having just one like two words as a point, and just one word as a point, and just this one as a point. Because when we ask for 5 results, it's just going to give us some meaningless information, some 5 points that just matches with the vector database name, right? It just matches like a similar text. So that's where vanilla RAG fails. And why graph RAG is better than this, because what happens in a graph RAG, when you store the information in a graph RAG, you use an LLM. Why do you use an LLM? To understand the sort of relation between those informations. So you pass the text into an LLM, it's going to give you those relations, it's going to map it in a knowledge graph. And when you do vector database, so it's going to find everything that's related to a vector from its knowledge graph. It's going to find everything that's basically, let's say if we are in Google and we say Elon, and if you see this, Google has this thing, right? This is not being written in one place. This is basically how Google has implemented knowledge graph. That was the first time knowledge graph was implemented. And because of knowledge graph, it's able to pull this related information. So if I say about Elon, and then if you see born, children, this, all of this is like a graph that has been stored. So in similar way, knowledge graph would help here, because if I say vector databases, we would ideally see the different names of vector databases here, and different things about vector databases would have come like a knowledge graph. That would help basically your LLM with more information, and would give you a better results. Right now this is of no use. I would get basically some nonsense as a answer from LLM. Proper hallucination we would have got in terms of RAG application. So this is something I wanted to showcase, why vanilla RAG will fail when it comes to large data sets, and how chunking matters, right? If I had put the whole entire point of this document, which makes sense, from here to here, this entire thing would, or if I say from here to basically here, then this entire thing would have come as one point, which I could have passed to an LLM. LLM would have made some sense out of this data. It would have read this and it would have understood Pinecone, Chroma are all basically the vector databases mentioned in this document, and it would have passed. But in this case, we are not able to retrieve this whole information at a time because of the chunking. We have not chunked it better. We couldn't chunk it better because when chunking, we have not used a natural language. Some sort of I think layout understanding, or any something like that is needed in order to store the information in a better way. So injection of document didn't happen well, because of which extraction of document also didn't happen well. All right, thank you guys.